Welcome. Over this series, we're going to build a complete doctor appointment app where patients book an appointment by simply chatting with an AI assistant. There's no clunky calendar to click through, no drop-down menus. The patient just types in plain English, "I've had a headache for 3 days. Who should I see?" And behind that little chat box, the AI reads our real database of doctors, checks each doctor's weekly schedule, writes an actual appointment into the database, and even offers to email a reminder the day before. I want you to notice how ambitious that sounds and how little code it will actually take. A few years ago, understanding a sentence like, "Book me with a heart doctor next Tuesday afternoon," would have been a research project. Today, it's a feature you can ship in an afternoon, and by the end of this series, you'll have built it with your own hands. We'll also build all the supporting pieces, so it feels like a real product, not a toy demo. There's an admin area to manage doctors and their availability, a page where patients can see their own appointments, chat history so they can reopen an old conversation, and a scheduled job that quietly emails reminders. By the finale, you'll have something you could genuinely put in front of a clinic. The engine for the smart part is the Laravel AI SDK. That's Laravel's own first-party AI package. Think of it as one clean, consistent way to talk to the big AI providers like Anthropic's Claude, OpenAI, and Google's Gemini. The huge win is that you write your code once, and switching providers is a one-line change. We'll use Gemini in this series because it has a generous free tier, which is perfect for learning without a credit card. Here's how the whole series is organized, so you always know where we are. In the first 2 episodes, we do all the boring but important groundwork. We set up the project and build the entire database up front, every table we'll ever need. After that, each episode adds exactly one feature on top of the last, and we never have to go back and redesign a table halfway through. That get the foundations completely done first approach is exactly how experienced developers avoid painting themselves into a corner. Let's start by creating the project itself. Before we can write a single line of AI code, we need a working Laravel and React project running on our machine. Now, the traditional way to do this involves installing PHP, installing Composer, installing Node, then typing a string of terminal commands, and hoping every version lines up. That's a lot of ceremony, and honestly, it's where a lot of beginners give up before they've even started. So we're going to skip all of that. We'll use Laravel Herd. Herd is a free desktop app that bundles PHP, a web server, and everything else you need into one installer. In the part 1 love, recent versions of Herd let you create a brand new Laravel project entirely through its interface, by clicking buttons, not by typing commands. That's exactly what we'll do. If you haven't installed Herd yet, pause here, go to the Herd website, download it for your operating system, and run the installer. It's a few clicks and it just works. The exact wording of the buttons can shift slightly between Herd versions, so if something is labeled a little differently on your screen, don't panic. The flow is the same, and Herd's own documentation is a quick search away. Let me walk you through it. Herd opens onto a list of your sites. A site is just a project that Herd is serving for you. Right now, this list is empty, or it has other projects. Look for the button to create a new site. It's usually a plus icon or a button that says New Site near the top of the site's area. Go ahead and click it. Next, make sure to choose React Starter Kit on Starter Kit selecting page. Give the project a name. I'll call mine the AI Doctor Appointment, something like Doctor Assistant. You can choose to opt in to install team support or change any other options here, but I will stick with what is given by default, and I will opt in to initialize a Git repository for you guys to follow along what I am doing. Watch what Herd is doing here because this is the payoff. In the background, it's downloading Laravel, installing all the PHP packages with Composer, installing all the JavaScript packages with NPM, generating your app key, and creating your database file. Every one of those commands you'd normally type by hand done for you. This can take a couple of minutes the first time, so let it finish. This is a great moment to grab water. When it's done, your new project appears in Herd site list, and next to it you'll see its address. Mine is ai.doctorappointment.test. Click that link, or type the address into your browser. And there it is, a real, running Laravel application, served securely over HTTPS, and we never touch the terminal. Notice the login and register links in the corner. Those came free with the starter kit. Let's click register and create ourselves an account. Put in any name, any email, and a password you'll remember. We'll be logging in as this user constantly while we test. One last thing before we move on. Let's open the project in our code editor. Throughout this whole series, I'll be using Cursor. It's a code editor built on top of VS Code. So if you've ever used VS Code, everything looks and works the same, the menus and shortcuts are identical, and you'll feel right at home. If you'd rather stick with plain VS Code, that's completely fine. Every step in this series works the same in both. In Herd, you can usually right-click the site to reveal in your files, or just open the project folder. Remember, it's in that Herd folder we accepted earlier, in Cursor. From here on, this is our home base. Now, I promised we'd create the project without the terminal, and we did. But from here on, for installing packages and running Laravel's own tools, we will use the terminal. That's the normal, everyday way Laravel developers work, and Herd has already made sure the right PHP is on your path. So open the built-in terminal in Cursor, the same integrated terminal you'd find in VS Code, and let's install the AI SDK with Composer, which is PHP's package manager. This is the command we need to run, so go ahead. While that downloads, let me tell you what we just pulled in. This is the Laravel/AI package, Laravel's official AI toolkit. It gives us 3 big building blocks we'll use across the series. Agents, which are AI assistants with a personality and a job. Tools, which are PHP functions the AI is allowed to call. And conversation memory, so a chat can remember what was said earlier. We'll meet all 3. When it finishes, Laravel automatically discovers the package. There's no manual registration step. Now we publish its config file and its migrations. Publishing just means copying those files out of the hidden vendor folder and into our own project where we can see and edit them. That command gives us 2 things. First, a configuration file at config/ai.php, where we choose our AI provider and paste our key. Second, a database migration that will create 2 tables for storing AI conversations. We'll run that migration in a few minutes, and we'll actually use those tables later so the assistant can remember a chat from one message to the next. Let's open that config file we just published, config/ai.php. At the very top, you'll find the default provider setting. Out of the box, it points at OpenAI. We're using Gemini, so let's change it. But rather than hard-coding Gemini, right here, we'll read it from an environment variable and just default to Gemini. Let me explain why we do it this way, instead of just typing Gemini. The env function reads a value from our .env file, and if it's not set, it falls back to the second argument, Gemini. This little pattern is a best practice you'll see everywhere in Laravel. Anything that might change between your laptop and a real server, or anything secret, lives in .env, not baked into your code. Today, it means you could switch the whole app from Gemini to Claude by changing one line in one file, without touching this code at all. Now scroll down to the provider's array and find the block for Gemini. Notice what's already here. It names a driver, it pulls an API key from the environment, and it has Gemini's base URL. We don't need to change anything in this block. Laravel has set it up correctly for us. All we have to do is supply the key it's looking for. Let's go do that. Open the .env file in the root of the project. This file holds all your machine-specific and secret settings. Let's add 2 lines to the AI SDK. The first line, AI_provider, is the exact variable our config file reads. So this is what actually selects Gemini. The second line is where our secret key will go. Right now it's empty. Let's go get a real key. To get a free key, open Google AI Studio in your browser, sign in with a Google account, and look for the Get API Key or Create API Key button. It generates a long string of characters. Copy it, come back to .env, and paste it right after the equal sign on the Gemini _ key line. I will not paste it live here, I will add it behind the scene, so you want copy and use my key, just use yours from Google. Now, a serious word about that key, because I've watched people learn this the hard way. Treat it exactly like a password. Anyone who has it can spend against your Google account. The reason we put it in .env is that Laravel's .env file is get ignored by default, meaning it never gets committed and never ends up pushed to GitHub for the world to see. There's a real war story behind this. Developers have accidentally committed API keys to public repositories and woken up to a huge bill because bots scrape GitHub for exactly these strings within minutes. So, key goes in .env, never in your code, never in a script. There's one more file to touch. Open .env.example. That's the template that does get committed, so teammates know which variables they need. Add the same 2 lines there, but leave the key value blank. That way you're documenting that the variable exists without ever leaking the secret. And one tip from experience that will save you a confusing afternoon later. When we choose a specific model in a couple of episodes, we'll use a stable one called Gemini 2.5 Flash. It's tempting to grab the very newest preview model, but on the free tier those newest models are often overloaded and will hand you back errors that look like your code is broken when it isn't. We'll set that stable model explicitly when we build the agent, so you don't hit that wall. Remember that migration we published a few minutes ago, the one for storing AI conversations? Let's run it now. In Laravel, running migrations is how you build your database tables from code. Watch the output. Laravel prints each migration as it runs and marks it done. This one creates 2 tables, agent_conversations and agent_conversation_messages. Let me make it concrete why they matter with a scenario. Imagine a patient's first message is, I think I need a cardiologist. Then their very next message is just book me for Monday. A human receptionist obviously remembers they were talking about a cardiologist. Without memory, an AI would have completely forgotten. These 2 tables are what let our assistant remember. The SDK will save every message here and reload it, so the conversation flows like a real one. We'll switch that memory on in episode 3 when we build the agent, and read from these same tables in episode 6 to show chat history. If you ever want to peek at your database and confirm those tables really exist, Herd ships with a database viewer, and there are great free tools like Table Plus, but you don't need to. If the migrate command finished without red errors, they're there. Let's take a breath and see how far we've come. We created an entire Laravel and React project using nothing but Laravel Herd's interface. No terminal gymnastics. We registered a user. We installed Laravel's official AI SDK, pointed it at Google Gemini, safely tucked our API key into .env, and ran the migration that gives our assistant a memory. That's a complete, running foundation. In the next episode, we build the entire database for the app in one focus sitting. Doctors, their weekly availability, appointments, and an admin flag on our users. Getting every table done up front is the single best decision we'll make, because it means every episode after this one gets to focus purely on features. See you there. In this episode, we build the entire database for the app, every table we'll need for the whole series. It's a longer episode, but once it's done, every future episode just builds features on top. No more touching migrations after this. We need 4 things: an admin flag on users, a doctor's table, a weekly availability table for each doctor, and an appointments table. And here's how we'll work. For each new table, We scaffold the model and its migration together in one command, then fill in the migration and the model side by side. It keeps each piece of the app in one tidy place. Let's go in that order. Later we'll have an admin area to manage doctors. Only admins should see it, so users need a way to be marked as an admin. Now, the user model and its table already exist. They shipped with the starter kit. We're not creating anything new here. We're modifying a table that's already there. So this is the one case where we reach for a plain migration on its own, not a model. Remember that distinction. New model plus new table means one command together. Changing an existing table means just a migration. PHP artisan make. Migration add underscore is underscore admin underscore to underscore users underscore table. That's the command we need to run. A single Boolean column, defaulting to false, so every existing and new user is a normal patient unless we say otherwise. While we're thinking about users, let's teach the model about this new column right away. Open the user model and add is_admin to its hashtag, fiable attribute, and its casts, so we can set and read it cleanly. Column added, model updated. Users are done. Now onto the tables we're building from scratch. Here's our first new model, and this is where the single command approach earns its keep. Instead of making a migration and then separately making a model, we do both at once with a -m flag. That one command just did two things for us. It created the doctor model and app models, and because of the -m, it also created the create_table migration. The M stands for migration. Laravel is even smart about the name. It saw the model was called doctor and named the table doctors, pluralized for us. If you ever want to scaffold even more in one go, -mf adds a factory too, and -a gives you the full set. But for us, model plus migration is exactly right. Let's fill the migration first. The shape of the table, name, specialty, and an optional bio. The specialty is what the AI will match a patient's problem against, rash to dermatologist. Now the model that -m created for us. We'll use the modern Laravel 13 style, PHP 8 attributes like hashtag, fiable, on the class, instead of the old protected $fiable property. The starter kit's user model already uses this style, so we'll stay consistent. Let's start with just the top of the model, the imports, the fiable attribute, and the two relationships, and we'll add the clever method afterwards. Notice the hashtag fiable attribute right above the class. That's the Laravel 13 way to declare which columns can be mass assigned. In older Laravel, you'd have written a protected $fiable property inside the class. The attribute on top is the modern replacement, and the starter kit's own user model already uses it. So we're staying consistent with the code that shipped with our project. Then two relationships. A doctor has many appointments and many availability rows. These let us write natural code later like doctor arrow appointments to get everything a doctor has booked. Now let's slow right down on the interesting method, slots for, because it's the quiet workhorse of this whole app, and I want to build it up a piece at a time rather than dropping it on you all at once. The problem it solves is this. A doctor doesn't store a list of appointment slots anywhere. They store, I work Mondays from 9 to 5. Somebody has to turn that into the actual bookable times, 9, 10, 11, and so on. That somebody is this method, and both our AI and our admin screens will lean on it, so it's worth getting right in one place. Let me walk through it line by line. The first thing it does is look up the doctor's availability for the weekday of the date we were handed. We ask Carbon for the day of week of the date, a number 0 through 6, and find the matching availability row. And here's the very first thing we handle, the failure case. If the doctor simply doesn't work that day, there's no row, so we return an empty array right away and stop. Handling the nothing here case first, before the happy path, is a habit that saves you from a lot of null-related crashes. If we get past that, the doctor does work that day, so now we generate the actual hourly slots. We parse the stored start and end strings, like 9 o'clock and 1700 hours, into Carbon time objects. Then we walk a loop from the start, adding 1 hour each pass, stopping before we reach the end, and each step records a slot formatted as hours:minutes. So 9 to 5 becomes 9, 10, 11, all the way to 4. Notice start.copy. Carbon objects are mutable, meaning add hour changes the object in place. So we copy first to avoid accidentally moving our start time. That copy is a classic subtle bug I want you to never hit. We centralize all of this here, so the AI and the admin screens can never disagree about what available means. Each doctor works different days and hours, so availability gets its own table. 1 row per working day, per doctor. Same approach, 1 command for the model and its migration. Model and migration, both created. And notice Laravel pluralized doctor availability into doctor_availabilities for the table name. It handles that awkward plural for us. Migration first. Day_week is a number from 0 to 6. I'm using the same convention Carbon uses. 0 is Sunday, so later our code lines up with no conversion. Start_time and end_time are simple strings like 9 o'clock, and the unique constraint means a doctor can have at most 1 window per day. Now the model. Same attribute style. Notice casts is a method that returns an array. That's also the Laravel 13 way, and it's how the user model does it. There isn't an attribute for casts, so this method stays. And the belongs to is the other side of the doctors has many from the last section. Now the model, everything revolves around. We build the table complete, including the columns we won't use until later episodes, like the reminder fields. Designing it once now means we never alter it again. 1 command as always. Let me highlight the important columns. Doctor_ID links to the doctor. User_ID links to the logged-in patient who booked. It's nullable, so we can stay flexible. Patient_name and patient_email are who we're booking. Schedule_at is the exact moment. Reminder_in records whether the patient wants an email reminder. The AI will set this. Reminder_at lets our reminder job avoid emailing twice. And the unique constraint on doctor_ID plus schedule_ means the database itself refuses to double book a doctor. The cast turns schedule_at and reminder_at into Carbon date objects, and reminder_opt_ and into a real true/false. 2 relationships. An appointment belongs to a doctor and to a user. That's all 4 models and all 4 migrations written. Every table has its model right beside it. Let's create the tables. You can verify the tables have been created using this command I use here. It gives the table summary. Let's eat an admin user and a few doctors with weekly schedules, so we have something to demo. Each doctor gets a different weekly schedule. That variety is deliberate, so the AI has real choices to reason about. We use first or create and update or create, so running the seeder twice never creates duplicates. Let's run the seeder now. A quick word on that command, because it's a sharp tool. Migrate. Fresh drops every table and rebuilds them from scratch. Then, seed runs our seeders. It's perfect right now while we're building, and there's no real data to lose. But burn this into your memory. Never run migrate. Fresh on a production database. It would wipe every real appointment and user in an instant. During development, it's your best friend. In production, it's a loaded gun. Before we celebrate, let's do something that separates confident developers from hopeful ones. Let's deliberately try to break our own database and watch it defend itself. Remember that unique constraint we put on doctor_ID plus scheduled_at? I claimed it stops a doctor being double booked. Claims are cheap. Let's prove it. We'll drop into Tinker, which is an interactive PHP playground wired into our app. Use this command to start a new session on Tinker. Now let's book the same doctor at the exact same moment twice, on purpose, and see what happens on the second attempt. These are 2 requests. We need to run them both at once. Press enter to see how it responds. The first one succeeds. You'll see a fresh appointment object come back. But watch the second one. It throws a big red query exception complaining about a unique constraint violation. That red error is exactly what we want to see. It means that even if a bug in our code, or 2 patients clicking at the very same instant, ever try to book one doctor into one slot twice, the database itself slams the door. This is defense in depth. We'll also check availability in our code, but the database is the final, unbreakable backstop. Type exit to leave Tinker. That's the entire database done. Users with an admin flag, doctors, their weekly availability, and appointments ready for everything to come. And we've seen with our own eyes that the double booking guard holds. We built each model and its migration together in a single command, and we will not touch a migration again for the rest of the series. Next episode is the exciting one. The AI agent and the tools that let it read and write all of this data. See you there. We have a full database. Now we build the brain, an AI agent and 4 tools. By the end, our backend can take a sentence like, book me with a cardiologist on Tuesday, and actually do it, using the doctors and availability we seeded last episode. 2 concepts. An agent is a PHP class representing one assistant. Its instructions and its tools. A tool is a PHP class the agent can call to get information or take an action. We'll build the 4 tools first, then the agent that uses them. Before we type, here's the mental model for a tool, because it's the single most important idea in this whole series. The AI model, Gemini, can't touch our database. It can't run a query. All it can do is read and write text. So how does it ever find a real doctor? We hand a menu of functions it's allowed to call, and we describe each one in plain English. When the model decides it needs one, it doesn't run the code itself. It tells the SDK, please call list_doctors for me. The SDK runs our PHP and hands the result back to the model as text. A tool is that bridge between the model's words and our real database. Let's build one method at a time, so it never feels like magic. Every tool implements 3 methods: description, handle, and schema, and we'll add an optional name method on top. Start with the class and the name. The name method sets the exact name the model sees for this tool. Clean snake case, list_doctors. If we left it out, the SDK would name the tool after the class, which works, but I like naming it explicitly, so the name I put in my agent's instructions later always matches. Now the description. Pay real attention to this, because the description is not documentation for you. It's an instruction the model reads to decide when to reach for this tool. This is prompt engineering hiding inside a normal PHP method. Notice I explicitly say, before checking availability or booking. That one phrase nudges the model to always grab a doctor's ID first, which is exactly the order we need. A vague description here is the #1 reason a tool never gets called, and beginners think their code is broken. Now the handle, the part that actually runs. Handle is just normal Laravel. Nothing AI specific here at all, which is the beauty of it. We query doctors, and the when method optionally filters by specialty only if one was passed. Notice request bracket specialty, then the $! null. That's the null coalescing operator, and it guards against the specialty being missing because we made it optional. Then the crucial part, we return each doctor as a line of plain text, and every line starts with a hash and the ID. That ID is the thread that ties all 4 tools together. The model reads it here, remembers it, and passes it to the availability and booking tools. And notice we handle the empty case by returning a friendly sentence, not a crash, because that sentence goes straight to the model to read. Finally, the schema. This tells the model what inputs the tool accepts. One optional string, specialty, with a description and an example, so the model formats it correctly. Because we did not chain a require call onto it, it stays optional, which lines up exactly with the null guard we wrote in handle. Schema and handle always have to agree. When they drift apart is when you get confusing errors. This tool answers, what times is this doctor free on this date? And it uses the slots for method we put on the doctor model last episode. We find the doctor by the ID the model gives us. If it's wrong, we return guidance so the model can recover. We ask the doctor for their slots on that date with slots for, which already knows their weekly schedule. If the list is empty, They don't work that day. Then we find the times already booked and the clever line, ray_diff, subtracts booked from available, leaving the free slots. The schema needs two required inputs, doctor_ID as an integer and date as a string. This is the tool that writes to the database, so it validates everything first. The name method, as usual, and then we update the description method with the instructions the agent should follow while using this tool. Look how many checks come before we write. Valid doctor, not in the past. The time is a real slot for that doctor that day, and not already taken. Only then do we create the appointment. 2 details. We set user_ID to auth ID, so the appointment is linked to whoever is logged in, which we'll use for the My Appointments page later. And the confirmation message literally tells the model what to do next. Ask about a reminder, then call set_appointment as a reminder. We can steer the model through the return value of a tool. The schema has 6 fields, doctor_ID, date, time, patient name, and email all required, plus an optional reason. I'll paste it. Each field has a description, so the model knows the exact format. This tool records whether the patient wants an email reminder. The actual emails come in the final episode. For now, we just store the choice. Let's look at the handle method. This is where the actual logic runs once the AI has gathered those 2 values. We start by querying the appointment model, looking for a match on the appointment_ID that came in through the request. Notice the when clause here. If there's an authenticated user, we scope the query to that user's ID. This is a security safeguard. It stops one user from updating somebody else's appointment just by guessing an ID. If we don't find a matching appointment, we return early with a plain language message. I could not find that appointment to update. That message isn't just for logs. It's what the AI will actually say back to the user. If we do find it, we cast the opt_in value to a Boolean just to be safe and update the reminder_opt_in column on the appointment. Finally, we return a dynamic confirmation message, either reminders turned on or reminders turned off, with the appointment number included, so the response feels specific and confirms exactly what changed. The schema method is where we define the contract, what information the AI model needs to collect before it can call this tool. Think of it as a form definition, but one the AI reads and fills in on its own. We're asking for two things. First, the appointment_ID, an integer required, and we've given it a clear description. Appointment ID from book_appointment. That description matters more than it looks. It tells the AI exactly where this value should come from, the output of a previous tool call, so it doesn't hallucinate a random number. Second, opt_in, a Boolean, also required. This captures whether the patient wants their reminder turned on or off. Now let's put it all together. This is the actual agent class that ties everything we've built into one conversational AI receptionist. At the top, we've got two attributes: provider set to lab, Gemini, and model set to Gemini 2.5 Flash. This tells the framework which AI provider and which specific model should power this agent. Swapping providers later is as simple as changing these two lines. The class implements three interfaces: agent, conversational, and has tools. Agent marks this as a runnable AI agent. Conversational means it can hold a back-and-forth conversation, remembering context as it goes. And has tools means it's allowed to call external functions, the tools we built earlier, like booking appointments or setting reminders. We're also using two traits, promptable and remembers conversations, which give us the underlying machinery for sending prompts and persisting conversation history, so we don't have to write that boilerplate ourselves. Now, the instructions method. This is the system prompt, the personality and rulebook for the agent. We grab today's date with Carbon and inject it directly into the prompt because the AI has no built-in sense of time. If we don't tell it the date, it can't reason about scheduling at all. The instructions set the tone, a friendly virtual receptionist for Lumen Health Clinic, and then lay out a strict 5-step workflow. Find a doctor, check their real availability, confirm the details with the patient, book the appointment, and always ask about the reminder afterward. That last line is doing a lot of work. Never invent doctors, times, or availability. This is our defense against hallucination. We're explicitly telling the model, don't guess, only use what the tools tell you. Finally, the tools method. This just returns an array of tool instances. List doctors, check doctor availability, book appointment, and set appointment reminder. This is what actually grants the AI its capabilities. Without this list, the instructions could ask for anything, but the model would have no way to act on it. Here's the magic. When we call prompt on this agent, the SDK runs the whole loop for us. It sends the tools to Gemini, and if the model calls list_doctors, the SDK runs your handle method, feeds the result back, and lets the model continue, calling check availability, then book, then set reminder, until it has a final answer. You never write that loop. The brain is done. Next episode, we give it a face, a chat screen where a patient actually talks to it. See you there. Our agent works, but right now nothing can actually talk to it. It's a brain with no mouth and no ears. In this episode, we build the chat screen, a controller that runs the agent, 2 routes to reach it, and a React page where a patient types a message and sees the reply come back. This builds straight on the agent we finished last episode. So by the end of these 30 minutes, you'll be booking a real appointment just by chatting. Let's go. Everything starts on the server, so let's make a controller. A controller is just the class that receives a web request and decides what to do with it. We'll generate one with an artisan command, PHP artisan make, controller assistant controller. Let's open this controller and start to work on it. This controller needs exactly 2 jobs, so it'll have 2 methods. The first simply shows the chat page. Let's write it. Index returns an inertia render of assistant/index. In an Inertia app, that line tells Laravel to load a React page component. The file will build in a few minutes, instead of a traditional blade template. So index is our doorway. Visit the page, and this hands you the React chat screen. Now the important one, the method that actually receives a chat message and talks to the AI. Let's start with just its signature and the validation. Notice the return type is JSON response, not a page, because this method answers a background request from JavaScript and sends back raw data, not HTML. Then we validate the incoming request. We require a message that's a string of at most 2,000 characters. That cap is a small but real defense, because without it someone could paste a novel and run up your AI bill. And we accept an optional conversation_ID, which will be null on the very first message of a chat, and filled in on every message after that. Next, we create our agent and decide whether this is a brand new chat or the continuation of an existing one. This little if-else is the whole secret to memory, so let's slow down on it. We make a fresh instance of the appointment assistant agent we built last episode. Then, if a conversation_ID came in, we call continue, handing it that ID and the current user. That tells the SDK to reload every earlier message in this thread so the AI remembers the context. If there's no ID, this is a new conversation. So for users starts a fresh one tied to the logged in user. Passing the user matters because it's how each conversation gets stamped as belonging to that person, which we'll rely on later for chat history. Now the single line that does all the heavy lifting. Prompt sends the patient's message to Gemini and runs the entire tool calling loop from episode 3 for us. Listing doctors, checking availability, booking, all of it, until the model has a final answer. We never write that loop. The SDK does. Then we return JSON with two things. The reply text, cast to a string with that string in parentheses in front of it, and the conversation ID. We hand the ID back to the browser, so it can send it with the next message and keep the same thread alive. That's the full round trip. A controller does nothing until a URL points at it. So let's wire up two routes. First, make sure the controller is imported at the top of the file. Now the routes themselves, inside the group that already requires the user to be logged in. A get route at /assistant shows the chat page, and a post route at /assistant/message receives each message the patient sends. Both sit inside the auth and verified middleware group, so only a logged in, verified user can reach them. That's deliberate. The assistant should always know exactly which user it's talking to, because it's booking appointments in their name. Now the fun part, the React page. Create a new file at resources/js/pages/assistant/index.tsx. We'll build it from the top down, a few lines at a time, so nothing feels like a wall of code. Start with the imports we'll need. We pull in 3 React hooks, useEffect, useRef, and useState, which we'll use for state and scrolling. Then input and button come from the starter kit's own UI components. So our chat matches the rest of the app for free, and send horizontal is just the little send arrow icon. Now let's describe what a single chat message looks like. This is a TypeScript interface, a shape. Every message has an ID, so React can track it, a role that's either the string user or the string assistant, and the content text. Typing this now means the editor will catch us later if we ever build a message wrong. Next, a small helper for the security token. Don't worry if this looks cryptic. Here's what it does and why. Laravel protects every post request with a seats_rf token, and it hands that token to the browser inside a cookie named XSRF token. This helper digs that value out of the cookie string and decodes it, so we can send it back to prove the request really came from our own page. We'll actually use in the next section, and I'll show you exactly what breaks without it. Now the component and its state. For pieces of state, and each one earns its place. Messages is the list of chat bubbles on screen, starting empty. Input is whatever the patient is currently typing. Loading is a true or false flag we flip on while we wait for the AI, so we can show a spinner and block double sends. And conversation ID holds the thread ID that came back from the server, so every follow-up stays in context. Last, let's set up auto-scrolling. Bottom ref is a reference we'll attach to an empty div at the very bottom of the message list. Then useEffect runs a small piece of code whenever the messages or the loading flag change, and it smoothly scrolls that bottom marker into view. The result is the chat always slides down to the newest message on its own, exactly like every messaging app you've ever used. A tiny touch that makes it feel real. Here's the heart of the page, the function that runs when a patient sends a message. We'll build it in 4 small steps. Step 1. Take the text, guard against nonsense, and show the message immediately. We trim the text to remove stray spaces, and if it's empty, or we're already waiting on a reply, we bail out early. That stops empty sends and double clicks. Then notice what we do next, because this is a professional touch called an optimistic update. We add the patient's own message to the screen right away, clear the input box, and flip loading on. The patient sees their bubble and a spinner instantly, before the AI has said a single word. That immediacy is what makes an app feel fast. Step 2. Actually call our backend. We use the browser's built-in fetch to post to our message route. Let's read these headers, because each one has a job. Content type and accept both say, we're speaking JSON in both directions. The XXSRF token is that security token from our helper. This is the line that keeps Laravel from rejecting us. And in a minute I'll delete it on purpose, so you see exactly what happens. XRequestedWith marks this as a background request. And the body is our message plus the current conversation ID, converted to a JSON string. Step 3. Handle the reply. First, we check residential.ok. If the server sent back an error status, we throw, which jumps us down to the catch block. Otherwise, we read the JSON. Then 2 things. We save the conversation as for ID the server returned, so the very next message continues this same thread, and we append the assistant's reply as a new bubble. That's the AI's answer landing on screen. Step 4. Deal with failure and always clean up. If anything went wrong, the network dropped, the server erred, the catch block shows a calm, friendly message instead of a broken screen or a scary console error. And the finally block runs no matter what, success or failure, turning loading back off so the spinner disappears and the patient can type again. Never leave a user stuck behind a spinner that never stops. Finally is how you guarantee that. Now, one question you might be asking. Why are we using raw fetch here instead of Inertia's useForm helper, which we'll happily use in later episodes? Because a chat is genuinely different from a normal form. A normal form submits and reloads the page's data. A chat needs to append one new bubble to a growing list without reloading anything and without throwing away the messages already on screen. Plain JSON over fetch fits that perfectly. This is a healthy lesson in itself. Reach for your framework's defaults most of the time, but know when a use case calls for stepping outside them. We've got all the logic. Now let's give it face. We'll build the visible part in pieces too. Start with the scrolling container that holds every message. Let's add this page to the sidebar so that the user can actually see the page rendering on their left sidebar of their application and be able to open the page. This will help us to build something that you actually see each change we made. Import the stethoscope icon from Lucide React library. We add one NAV item pointing at /assistant with a stethoscope icon to fit the theme. Make sure stethoscope is imported from Lucide React at the top of the file, and now the assistant is one click away from anywhere in the app. That's done. Now continue with the markup thing. This is a centered column that fills the height of the screen. The inner div is the message area. Flex, one tells it to take up all the leftover space, and Overflow Auto gives it its own scroll bar, so the messages scroll while the input box stays put at the bottom. Now let's render the bubbles. We loop over every message and draw a bubble. The clever part is the conditional classes. If the role is user, we justify end, pushing the bubble to the right and coloring it with our primary color. That's the classic my messages on the right look. Otherwise, it stays left with a muted gray. And whitespace pre-wrap is a small but important detail. It preserves the line breaks the AI sends, so a list the assistant writes actually shows as a list instead of one run-on line. Next, the loading indicator and our scroll marker. While loading is true, we show a gentle pulsing, thinking line because the AI genuinely takes a second or two, especially when it's calling tools behind the scenes, and a visible cue reassures the patient that something is happening rather than frozen. And there's that empty div with our bottom ref attached. The invisible marker our auto scroll effect jumps to. Finally, the input form. The form's onSubmit calls e.preventDefault first, which stops the browser's default full-page reload, then runs our send function with the current input. The input is a controlled field. Its value comes from state, and every keystroke updates that state. Notice both the input and the button are disabled while loading, so a patient can't fire off two messages at once, and the button also disables when the box is empty. Autofocus just drops the cursor into the box the moment the page loads, so they can start typing right away. That's the whole page. Here the form does not renders on our screen. Let's debug to see why. Here you can see that the return statement that carries all our markup is inside the async function called send. This is wrong, so we need to cut it and put it outside the async function. This is a common mistake you can make while coding, and it is good to show you, as it may help save you a whole day of debugging alone if you ever have a bug like this one. Make sure to do what I am doing here, so we can have our page render correctly. Perfect. On screen, you can see the input, is now visible on the screen. But we have one problem. The input is a bit smaller in width than expected. We missed some Tailwind CSS classes here. Let's fix it. Add the flex-call1 to add a flexing column on the div. Add a width full class here, so the outer div will take the whole available width. Now let's test the whole thing. Make sure to set your Gemini key in .env file. Open the assistant from the sidebar and type, "I keep getting chest pains. Who should I see?" Perfect. It found Dr. Okoro. Now I'll answer the way a real person answers. Short, assuming the assistant was listening. Book me Tuesday at 2 p.m. There it is. Amnesia. It just named the doctor. I just gave it a day and a time, and it throws it all away and asks me again like a headless chicken. There are two bugs here. It isn't using the conversation as memory, and it won't turn the word Tuesday into an actual date. Plus, there's a behavior it's missing entirely. When a date doesn't work, it should show me when the doctor is free, not just bounce me. Let's fix all of it, and notice how little code it actually takes. Let's fix this by starting with updating the agent class itself. First line of the method. Right now we hand the model July 6th, 2026. The model counts forward better if it knows today is Monday, so let's include the weekday. Quick carbon detail worth knowing. That format string isn't arbitrary. Lowercase l means full weekday name. F is full month name. J is day without leading 0, and Y is the 4-digit year. Carbon is just wrapping PHP's native date, format characters. So this same cheat sheet works anywhere you format a date in PHP. Now it reads, Monday, July 6th, 2026. Small change, big payoff for date math. Now the instructions themselves. Select the whole here doc. Everything from return, instructions down to the closing instructions, and we'll rewrite it. We add, use the conversation as your memory, and then, this is the important trick. We quote back the exact failing sentence, book me Tuesday at 2 p.m., and tell it precisely what should happen with that sentence. This is a technique called few-shot correction. Instead of describing the rule abstractly, you hand the model the specific input that broke it, paired with the specific behavior you want. Same logic for the date resolution. Resolve dates yourself. Works because we already gave it today's date, with the weekday at the top of the prompt. The model can now do actual calendar arithmetic. Today is Monday the 6th, so Tuesday is the 7th, entirely in its own reasoning before it ever calls a tool. And step 2's new branch. If that day is full or off, scan the week with days equals 7. Is us pre-teaching the model a tool capability that doesn't exist yet. Open app/ai/tools/checkDoctorAvailability.php. Today this only checks one date. We'll teach it to scan a range, so it can offer alternatives in a single call. This string isn't a code comment. It gets sent to Gemini as part of the tool's definition, alongside its name and its parameters. It's literally the only information the model has about when and why to call this function. There's no separate documentation. The AI reads. The description is the documentation. So when we mention days equals 7 here, we're not configuring anything. We're persuading the model, in plain English, that this parameter exists and telling it exactly when to reach for it. Select everything inside handle and swap it for a version that loops across days. I'm also pulling the free slots for one date logic into its own helper, free slots for, so the loop stays readable. Let's walk this line by line, because there's real logic packed in here. $start equals carbon. Parse, $request, date, dash, start of day. Same as before, We take whatever date string the AI passed in and normalize it to midnight, so time of day never leaks into our comparisons. $days equals max 1, min, int, $request days 1, 14. This is a clamp, and it's doing 3 jobs at once. The null coalescing operator 1 means if the model doesn't pass days at all, like on a normal single-day check, we default to checking just 1 day, so old behavior keeps working untouched. Then min, 14, caps it so the model can't accidentally ask us to loop over, say, 400 days and hammer the database. And max, 1, protects the other end. If the model somehow sends days, 0 or a negative number, we still check at least 1 day instead of returning nothing. Always clamp numbers that come from an AI's output. It's a well-behaved client almost all the time, but almost all isn't good enough for a loop bound. Then the loop itself. $date equals $* copy, -add days, $offset. Notice the copy call. Carbon objects are mutable, so without copy, we call $this dash free slots for $doctor, $date. That's the helper we're about to write. It hands back an array of open time strings for that 1 day. Now the branching logic, which is really the heart of the feature. If days, 1 in and empty, free, continue. This line only fires when we're doing a range scan, not a single day check. If we're scanning a week and this particular day has nothing open, doctor's off or fully booked, we just skip it silently with continue and move to the next day. That's what makes the output clean. The patient scanning a week only sees days they can actually book, not 5 lines of sorry, nothing here. Right below the handle, method, add this helper. It's the old single-day logic plus one nice touch. It filters out any time that has already passed a day, so we never offer a 10 a.m. slot at 2 p.m. This is basically the exact block we deleted from handle a minute ago, moved into its own method, so we're not repeating it 14 times inside the loop. That's the whole point of the refactor, nothing more exotic than that. Two details worth flagging, though. Laravel Herd if $slots, $booked, is a plain set subtraction. Take every slot the doctor offers, remove every slot that's already booked in the appointments table, and what's left over is what's free. Simple, but it's the core of the whole availability check. The new piece is the array_filter wrapping it. Carbon, parse, $date dash to date string, $time dash is future. We rebuild a full datetime string by gluing the date and the time slot together, parse it back into a real Carbon instance, and ask is future. That comparison is always against right now, wall clock time. So if it's 2 p.m. today and the 10 a.m. slot is technically free in the database, nobody booked it, we still hide it because it's already gone. Without this filter, the assistant could confidently offer a patient a time slot that's already passed, which looks broken even though technically the data was correct. Notice days has no dash required on it. That's deliberate. Everything else in this schema is required because the tool can't run without a doctor and a starting date, but days is genuinely optional. Leaving off required tells Gemini it's fine to omit this parameter entirely on a normal call. And our one default back and handle is exactly what catches that omission. Schema and handler have to agree with each other. If we'd mark this required, the model would feel obligated to invent a number every single time, even for plain single-day checks. That's the whole feature. 1 day in, 1 day out, exactly like before. 7 days in, a whole week of options out, with the off days hidden. And nowhere in this file did we write a rule like if Friday is full, suggest Tuesday. We just build a tool capable of looking further, describe that capability honestly, and let the model and the instructions file decide when reaching for it makes sense. While we're here, One quick bug I spotted. Open app/ai/tools/listdoctors.php and look at the schema at the bottom. The parameter is spelled specialty with an I, but up in handle, we read $request, specialty no I. They never match, so the specialty filter silently does nothing. One letter fix. This one's a good teaching moment on its own. Actually, this bug produced 0 errors, 0 exceptions, nothing in the logs. PHP arrays don't complain when you read a key that doesn't exist under a strict schema like this. Request specialty just silently comes back empty, and the filter logic in handle treats no filter given as show everyone, which is a perfectly valid, unremarkable code path. That's exactly why it's dangerous. The tool always ran. It just quietly ignored the one argument that mattered. Here's another part that surprised me when I debugged this. My first instinct was the instructions are too weak. But watch closely. The assistant loses its mind specifically when I give it a date, and it's fine when I hand it a doctor's name in the same message. That's the tell. It isn't forgetting because the instructions are bad. It's forgetting because it never receives the previous messages at all. Each turn, the model only sees what I just typed. This looks harmless. Return the messages so far, but it's returning an empty array, always. And here's the trap. Our class already uses the remembers conversations trait, and that trait already provides a messages method, one that loads the real conversation history out of the database. By declaring our own messages here, we were silently overriding the trait's version and handing the model nothing. Total amnesia, every single turn. So the fix is to simply delete this method and let the trait do its job. And because we no longer reference the message type in a doc block, we can drop its import up to the top 2. That's the real bug fixed. Everything's saved. Back to the assistant. Fresh conversation. I keep getting chest pains. Who should I see? Now the exact line that broke it before. Book me Tuesday at 2 p.m. Watch the tool calls. It remembered Dr. Okoro, ID 2, and turned Tuesday into July 7th on its own. 2 p.m. to 1400 hours is right there. So instead of reinterrogating me, it just asks for the one thing it's actually missing. So it has booked the appointment for us just by chatting with the AI, and at the end we have everything we wanted with easy. And the proof it's real, the database. A real row in our real database. The doctor, the date it worked out itself, the time, the reminder flag, created by an AI that understood plain English and never once made me repeat myself. Step back and notice what we did not do. We never wrote, if chest pain, pick the cardiologist. We never wrote, convert Tuesday to a date. We never wrote, if Friday's out, offer Tuesday. Every one of those came from the model reasoning over clear instructions and 4 well-described tools. What we actually changed was tiny. Told it to use the conversation as memory, told it to do its own date math, gave one tool an optional days parameter, and fixed a 1-letter typo. That's the whole lesson. When an agent misbehaves, reach for sharper instructions and better tools before you reach for hard-coded logic. Describe the world clearly and get out of the way. Next episode, we build the admin area so a clinic can manage its own doctors and their weekly schedules. The very availability this assistant is already reading. See you there. So far, our doctors only exist because we seeded them by hand. A real clinic needs to manage its own doctors, add new ones, edit hours, remove someone who's left. In this episode, we build an admin-only area to do exactly that, and crucially, to set each doctor's weekly availability, which our AI already reads when it books. This builds on everything so far, the is_admin column from episode 2, and the very same availability data the assistant uses. Let's start with the lock on the door. Before we build any admin page, we need a gate, because these pages let someone change the clinic's data. In Laravel, the tool for check something before a request is allowed through is called middleware. Think of it as a bouncer standing in front of a group of routes. Let's generate one. The generated file has a handle method. This is where the bouncer does its one check. Let's read this carefully. We look at the logged in user and check there is _admin flag. Notice the question mark after user parentheses. That's the optional chaining operator, and it protects us if somehow there's no user at all, so we never crash trying to read a flag off nothing. If they're not an admin, we abort with a 403, which is the HTTP status for forbidden. I know who you are, and you're not allowed. Otherwise, we call next request, which means you pass, carry on to the page. That one method is the whole security gate. Now Laravel needs to know this middleware exists under a short name. In Laravel 13, middleware is registered here in bootstrap/app.php. Inside the with middleware section, we're giving our class a nickname, the alias admin, so that in our routes file we can just write middleware admin instead of the whole class name. Small thing, but it keeps the routes readable. Now the controller that does the real work, listing, creating, updating, and deleting doctors, plus saving their availability. We'll put in an admin subfolder to keep admin code together. Let's start with the method that shows the list of doctors. Index renders our React admin page and hands it every doctor. Notice with availabilities, that's eager loading. Without it, the page would fire a separate database query for each doctor's schedule, which is the classic N+1 problem that quietly kills performance once you have a few hundred rows. Loading them together in one query is the professional habit. Now, before we create or update, we need to validate the incoming data, and both actions need the exact same rules. So let's write that once as a private helper. The top 3 rules cover the doctor themselves. Then it gets interesting. Availabilities is an array, and the line with the star validates every single item inside that array. That star is a wildcard meaning for each row. So we're saying each availability row must have a day_week between 0 and 6, and start and end times that match the regular expression 2 digits, a colon, 2 digits. In other words, exactly the shape, 9 o'clock. Validating each nested row like this stops a malformed schedule from ever reaching your database. Now the create action. Make sure to import all helper classes we need. Store validates first, then creates the doctor using only the name, specialty, and bio. That's what ARR only does. It plucks just those keys, so the availability array doesn't accidentally get passed to the doctor row. Then it hands the availability off to a helper wheel right in a second and redirects back to the list. Update is almost identical. The only differences from store, Laravel automatically finds the right doctor for us from the URL. That's the doctor in the method signature, called route model binding, and we call update instead of create. Same validation, same availability sync, same redirect. Deleting is even simpler. Destroy just deletes the doctor and redirects. And remember from episode 2, we set the availability and appointment foreign keys to cascade on delete. So removing a doctor cleanly removes their schedule too, with no orphaned rows left behind. Finally, that availability helper both store and update lean on. This looks almost too simple, and that's the point. Instead of trying to figure out which days changed, which were added, which were removed, fiddly, bug-prone diffing, we just delete all of this doctor's availability rows and recreate them from what was submitted, passing the 3 columns in explicitly. For a small weekly schedule of at most 7 rows, this wipe and rewrite approach is the cleanest and safest choice. Knowing when the simple approach beats the clever one is a real engineering skill. Let's expose those controller methods as URLs and put our bouncer in front of all of them. Import the controller at the top first. Now the route group, inside the existing auth group. Here I did a mistake that you need to correct it. I put the route outside the auth middleware, but it is a good idea to put it inside an auth middleware group above. Make sure to do so. This will prevent any user that is not yet logged in to try to access this page. Read the chain left to right, because each piece does one job. Middleware admin puts our ensure user as admin bouncer in front of every route in this group. Prefix admin means every URL starts with /admin name admin. Means every route name starts with admin. Which is why we could write admin.doctors index earlier. And route resource is a shortcut that generates a full set of CRUD routes in a single line. We chain only to keep just the 4 we actually built. 1 line, 4 wired up, fully protected routes. The backend is done. Everything from here is the React page. Now the React page, and this is the biggest file of the episode, so we're going to build it piece by piece and explain every single part. The table, the dialog, the form fields, the buttons, all of it. But first, TypeScript needs to know what a doctor looks like. So let's give ourselves a shared type we can import anywhere. In this new file, we're going to write the shared interfaces that we will import anywhere we need them. 2 interfaces that mirror our 2 database tables. A doctor availability is 1 working day. Which doctor, which day of the week using the same 0 as Sunday numbering as Carbon, and the start and end times as strings. A doctor has an ID, name, specialty, an optional bio. Note the string or null, because bio is nullable in the database, and a list of those availabilities, which is exactly the shape our controller sends thanks to the eager loading. This file is re-exported from our types index, so pages can just import from @/types. Now the page itself. Before any logic, here's the design problem that shapes this whole file, because it drives everything. Our database stores only the days a doctor actually works. But a good editor should show all 7 days, with the working ones ticked, so an admin can just check and uncheck. So we need to translate between only working days in the database and all 7 days in the UI in both directions. Keep that in mind as we build. Start with the imports. A quick tour, so nothing later is a surprise. From Inertia, we take head to set the browser tab title, router to send the delete request, and use form for the form. More on that soon. From list side React, 3 icons, a pencil for edit, a plus for add, and a trash can for delete. Use state from React for our dialog state, and toast from Sonner for the little success pop-ups. Then 5 UI components from the starter kit's shack and library, button, checkbox, dialog, input, and label. And finally the doctor type we just wrote. Below the imports, the props this page receives. Just one prop. The array of doctors our controller's index method sends over. Now the 7 days. Days pairs each weekday number with a short label. In Monday first order for a natural looking week. And notice Sunday is 0 at the end. Matching the carbon convention we committed to back in episode 2. A day row is one row in our editor. Which day it is, whether it's enabled, and its start and end times. Build days always returns all 7 rows. For each day, it looks to see whether this doctor already has availability for it. If they do, the row is enabled and pre-filled with their real hours. The slice 0,5 just trims a stored 9 hours down to 9 o'clock for the time input. If they don't work that day, the row still appears but stays unticked, defaulting to a friendly 9 to 5. So an empty new doctor and a fully booked existing one both produce a clean 7-row grid. One more small helper before the component. Working days label builds the text for the working days column in our table. It walks the 7 days in order and keeps only the ones this doctor has availability for. That's the filter with some, which asks, does at least one availability match this day? Then it maps the survivors to their short labels and joins them with commas. So a doctor who works Monday, Wednesday, and Friday shows up in the table as Wed Friday. And if a doctor has no availability at all, we return a dash instead of an empty cell, so the table never looks broken. Because we filter days rather than the doctor's rows, the labels always come out in weekday order no matter how the database returned them. Now the component itself, starting with its state. The component receives the doctor's prop and keeps 2 pieces of state. Open is a simple true or false. Is the dialog showing right now? Editing is the clever one. It holds the doctor currently being edited, or null when we're adding a new one. That single variable is how one dialog serves both jobs. Null means add mode. A doctor means edit mode. Watch how many times we check it through this file. Next, the form. Here we're back to Inertia's use form, the helper I said we'd use for normal forms. And a doctor form is exactly that. Unlike the chat, it holds a name, specialty, bio, and our 7-day rows, starting from build days of null, 7 blank, unticked days. Use form tracks the values, knows when it's submitting, and collects validation errors from the server automatically. You'll see all 3 of those powers used before this file ends. Now, 2 functions to open the dialog, one for adding, one for editing. Open Create runs when the admin clicks the Add Doctor button, and it does 4 deliberate things. First, set editing to null. We're in add mode. Second, reset the form to blanks with a fresh set of 7 unticked days. Third, and this is the step people forget, clear any leftover validation errors. Without it, if a previous save failed, the new dialog would open already covered in red error messages for a doctor you haven't even typed yet. And fourth, open the dialog. Now it's mirror image. Open Edit takes the doctor whose pencil icon was clicked. This time editing gets that doctor, edit mode, and the form is pre-filled with their real values. 2 details worth pausing on. Bio, double question mark, empty string. Bio can be null in the database, but a text input can't hold null, so we fall back to an empty string. In build days of doctor, our translator again, but now with a real doctor, so their working days come back ticked with their actual hours. Same error clearing, same open. Now the one function every control in the availability grid will call. Update day changes one field of one day row. It takes the row's index and a patch. Partial of day row means any subset of a day row's fields, so you can pass just enabled true or just a new start underscore time. Inside, we map over the days and rebuild the array. For the one row whose position matches the index, we spread the old row and then spread the patch over it, so the patch fields win. Every other row passes through untouched. This is the standard React way to edit one item in a list. You never modify state in place. You build a new array where only one entry changed, and React renders exactly what it needs to. Now the submit function. This is where the second translation happens, from UI shape back to database shape. Let's take it top to bottom. Prevent default stops the browser's old school full page form submission. We're handling it ourselves. Then the star of the method, form.transform. It reshapes our data at the last second, right before it's sent. Remember, the UI works with all 7 days, but the server only wants the real working ones. So transform filters down to just the enabled days, and the map with the curly braces and its arguments destructures each row to keep only day_week, start_time, and end_time, dropping the enabled flag entirely. What leaves the browser is exactly the availabilities shape our validator expects. This is the other half of the translation build days started. Next, we prepare an options object with an onSuccess callback. When the server says all good, pop a success toast with a message reading the editing state, updated versus added, and close the dialog. Finally, the actual send. If we're editing, put to that doctor's URL, which hits our update method through route model binding. Otherwise, post to create a new one. And if validation fails instead, no toast. The dialog stays open, and useForm quietly fills form.errors, which our fields are about to display. One action left, delete. Deleting is destructive, so we ask first, using the browser's built-in confirm dialog. Click cancel, and the function simply returns, nothing happens. Notice the message is honest. It names the doctor and warns that their appointments go to, because of that cascade rule from episode 2. Never let a delete do more than the user was told it would. If they confirm, router.delete sends a delete request to our destroy route and toasts on success. The component returns 2 big pieces, the page with its table and the dialog. Page first. The admin page exists, but there's no link to it yet, and that link should only appear for admins. First, let's read the logged in user, which the starter kit shares with every page. Use page gives us the shared props Inertia sends on every request, and auth.user is the current user, including our is_admin flag from episode 2. Now let's build the NAV list and slip the admin link in only when appropriate. The first two items everyone sees. The third line is a conditional spread. If the user is an admin, we spread in a manage doctors link. If not, we spread in an empty array, so the item simply isn't there. The three dots are the spread operator. In this pattern, spread, a one-item array, or nothing, is the clean way to conditionally include a list item in React. A normal patient never even sees the link exists. Time to see all of it working. Here, you can see the new link is added, the Manage Doctors on the sidebar. Now the page is blank, so let's write our markups for this page. Head sets the browser tab title to Manage Doctors. Then the page header. Justify between pushes the doctors heading to the left edge and the button to the right. A layout you'll use on almost every index page you ever build. The Add Doctor button carries the plus icon and calls Open Create, the add mode opener we wrote a moment ago. Under the header, the table. A plain HTML table. No library needed for this. The wrapper div gives it rounded corners and a border matching the rest of the app. And overflow hidden is what makes the rounding actually clip the table's square corners. The header row has 4 columns. Name, specialty, working days, where our working days label helper will shine, and actions, right align because buttons sit best against the right edge. The slightly tinted background on the header visually separates it from the data. Now the body, and we start with the case beginners always forget. The empty state. If there are no doctors, we render one row whose single cell spans all 4 columns. That's call span 4, with a friendly, centered message that tells the admin what to do next. Always design the empty case. If an admin deletes the last doctor, this is the screen they'll see, and a blank table looks like a bug. Now the real rows. We map each doctor to a table row, keyed by ID, so React can track them. The name gets a heavier font weight, so it reads as the row's title. Specialty and working days are muted gray supporting detail, and there's our working days label doing its job, turning raw availability rows into wet Friday at a glance. Then the actions cell, 2 ghost buttons, which means no background until you hover, so the table stays calm. The pencil calls open edit with this row's doctor. That's how the dialog knows who you clicked. The trash can calls destroy, and its icon is tinted with text destructive. The theme's red, a quiet visual warning that this button is dangerous. That closes the table and the page half of the markup. Now the second half of the return, the dialog that hosts our form. It sits after the page div as a sibling. The dialog is controlled by our open state, and on open change hands control back the other way. When a user presses escape or clicks outside, the dialog calls set open false for us, so it closes properly without any extra code. On the content, Max H90VH with overflow auto means the dialog never grows taller than 90% of the screen. With 7-day rows plus 3 text fields, it can get tall on a laptop, and this makes it scroll instead of clip. And look at the title. It reads the editing state, Edit Doctor or Add Doctor. Same dialog, honest label. Now the form, field by field. The form's onSubmit is wired to our submit function, then the name field, and this 3-line pattern is worth learning by heart because you'll write it for every field in every form. A label linked to the input by HTML, so clicking the label focuses the field. A controlled input, its value reads from form data, and every keystroke writes back through form set data. And then the error line. Form errors that name is filled automatically by useForm whenever the server's validation rejects the field. Remember our required rule in the controller. And this paragraph only renders when there is an error, in red. Submit an empty name, and the name field is required appears right here, under the exact field that failed, with 0 extra plumbing. That is why we love useForm for normal forms. 2 more fields, same pattern. Specialty is a carbon copy of name, error line and all. Bio is the same pattern with 1 deliberate omission, no error line. Look back at our validation rules. Bio is nullable, so it can never fail validation, and an error slot that can never fill is just dead code. Small decisions like that keep files honest. Now the centerpiece, the weekly availability grid. We map over the 7-day rows in the form and draw each one as a horizontal strip. A checkbox, the day's label, then 2 native time inputs with a word to between them. Every control routes through update day with a rows index. The checkbox patch is enabled, wrapping the value in Boolean because the component can report an indeterminate state we don't use. The first time input patches start_time. The second patches and _time. 1 row changes. The other 6 are untouched. Exactly what update day was built for. The day label comes from a find against days by value, so the numbering and the words can never drift apart. And the nicest touch, both time inputs are disabled until the day is ticked. Disabled equals not day.enabled. So it's physically impossible to set hours for a day the doctor doesn't work. Gray means off. Editable means on. The form explains itself. Last piece of the form, the footer buttons. Two buttons, and both have a detail that matters. Cancel is explicitly type button. This is a classic gotcha. Inside a form, a button's default type is submit, so without this one word, clicking cancel would submit the form instead of closing the dialog. The real submit button is disabled while form.processing is true. useForm flips that flag on while request is in flight, which means an impatient double-click can't create the same doctor twice. And its label checks editing one last time. Save changes when editing, add doctor when adding. That closes the form, the dialog, and the component. One final line below the component. The same layout convention our other pages use. It wraps the page in the app shell with the sidebar and puts a doctor's breadcrumb at the top. The file is complete. 2 translators, 5 functions, a table, and a dialog, and every line of it explained. Here's a mistake I see all the time, and I want to inoculate you against it right now. We just hid the Manage Doctors link from non-admins. It is very tempting to think, great, non-admins can't reach the admin area anymore. That is false, and believing it is exactly how real apps get breached. Hiding a link in the UI is a convenience, not a lock. Anyone can just type the URL into the address bar. Let me prove both halves of this so it sticks. First, let's turn our own account into a non-admin. Then try the URL directly. Now, in the browser, type /admin/doctors into the address bar yourself. No link needed. And there it is, a big 403 forbidden page. That's our ensure user is admin middleware doing its job. It checked the flag on the server, saw non-admin, and slammed the door. That server-side check is the real lock. The hidden link was only ever about a tidy interface. Let's switch admin back on. The lesson to carry with you forever. Never rely on hiding UI for security, because the UI is just a suggestion the browser is free to ignore. Always guard on the server too. We did both. The link is hidden for a clean experience, and the middleware is the thing that actually keeps people out. Admins can now add, edit, and remove doctors and set their weekly schedules. And here's the payoff that ties this episode to the AI. Because the assistant reads the very same availability table, any change an admin makes here instantly changes what the assistant offers patients. Edit Dr. Chin's Friday hours, and the AI knows before you've even refreshed the chat. Next episode, we turn to the patient's side, a page where they can see their own appointments and the ability to reopen and continue a past chat. See you there. Patients can book through the assistant, but right now they can't see their bookings afterwards, and they can't go back to an old chat. Let's fix both. First, we'll build My Appointments page. Then we'll add chat history onto the assistant we built in episode 4. Here's the nice part. We're not adding any new tables or data. Everything we need already exists. The user_ID we saved on each appointment back in episode 3, and the conversation tables the AI SDK created for us all the way back in episode 1. This episode is about surfacing data we already have. Let's start on the server with a controller to fetch a patient's appointments. It needs one method, index, that lists the appointments belonging to whoever's logged in. Let's read this query piece by piece, because every line is deliberate. With doctor, and notice the colon with ID, name, specialty. That eager loads each appointment's doctor but pulls only those 3 columns, so we're not dragging back data the page never shows. Then the crucial line, where user_ID equals the current user's ID. This is what makes a My Appointments. A patient only ever sees their own. And this is exactly the same ownership thinking we'll lean on hard later in this episode. We order by scheduler_at, so the soonest appointment is first, and hand the list to our React page. Now let's give a URL. Here, I will correct one thing. I will cut and paste the admin routes group to be inside the auth middleware group, so only the logged in users can access the page. Then, add the My Appointments route. One get route at /appointments. Inside the auth group, so only logged in patients reach it. That's the backend for this page, completely done. Before the page, TypeScript needs to know the shapes we'll be working with. Let's open our clinic types file and add 3 interfaces, 1 for this page, and 2 we'll need in the second half of the episode, so we only visit this file once. Appointment mirrors our appointments table plus the doctor we eager loaded. And notice the doctor property has exactly the 3 fields our controller selected: ID, name, specialty. The types and the query agree, which is the whole point of writing them by hand. Reason is string or null because it's optional in the database. Then the 2 for later. A conversation summary is 1 row in the history list, ID, title, and when it was last updated. And a conversation message is 1 bubble in a reloaded chat, with a role that can only be user or assistant. Keep those 2 in the back of your mind. They'll click into place in section 4. Let's create the page and appointments directory. Now the page, and we'll build every part of it. Imports first. From Inertia, Head for the tab title and link for client-side navigation. A link swaps pages without a full browser reload, which is the whole Inertia experience. 2 icons. A ringing bell for the reminder indicator and a calendar for the empty state. A badge for the status, a button, and the appointment type we just wrote. The page receives 1 prop, the appointments array from our controller. Next, a small date helper. The database sends scheduled_at as a plain string, which would render as something robotic like August 3rd, 2026, 9 o'clock. Format when turns it into a date and asks the browser's to-locale string to print it nicely. The undefined first argument means use whatever language and region this visitor's browser is set to. So a patient in Dar es Salaam and a patient in Berlin each see their own familiar format, for free. The options ask for a short weekday, numeric day, short month, and 2-digit hours and minutes. Something like Mon, 3 August, 9 o'clock. Never show raw database timestamps to humans. Now the component, starting with the header. The max W2XL with MX Auto keeps the list a comfortable reading width, centered. Same trick as our chat page. The header row puts the title on the left and a book another button on the right. That as child prop is worth a sentence. It tells the button component, don't render your own button element. Style the child I gave you instead. So we get a link with all of Inertia's smooth navigation, dressed as a button. It's the standard way to combine Shack buttons with Inertia links. Now, before the list, the empty state because a brand new patient sees this screen first. A ternary. If there are no appointments, render this friendly card instead of an empty list. A muted calendar icon, a plain sentence saying what's going on, and, most importantly, a button that leads somewhere useful. Talk to the assistant. A good empty state always answers 2 questions. Why is this empty? And what should I do about it? A blank page answers neither. Now the list itself, 1 appointment per row, and each row has a left side and a right side. We map the appointments in a list items, each a bordered card with justify between splitting it into 2 sides. The left side stacks 4 lines, the doctor's name in a stronger weight, so it reads as the card's title. There's specialty in muted gray, then the date and time through our format when helper. And the 4th line only renders when there's something to show. Reason is nullable, so we guard it with a double ampersand pattern. If the patient told the assistant why they were booking, we show reason and their words. If not, the line doesn't exist and the card stays compact. Now the right side. The right side is a small column, aligned to the end. On top, a status badge, booked, with capitalized making the lowercase database value read nicely. And below it, a genuinely satisfying moment. The little ringing bell with reminder on only appears when reminder opt-in is true. And that's the exact flag our AI set through the set appointment reminder tool back in episode 3. A decision the model made during a conversation is now visibly surfaced on the patient's own page. The whole app is connecting up. That closes the list, the ternary, and the component. 1 line remains below it. Now the second half, chat history. Cast your mind back to episode 1. When we ran that migration, the AI SDK created 2 tables, agent_conversations and agent_conversation_messages. Every single chat a patient has had is already sitting in there. We never have to build storage, we just have to read it. Let's extend the assistant controller. First, Index needs to also send the user's recent conversations to the page. We query the agent_conversations table directly with the DB query builder. There's no eloquent model for it, and that's fine. The query builder is perfect for reading a table the SDK owns. We scope to this user's conversations, put the most recently updated first, cap it at 30 so the list never grows unwieldy, and grab just the ID, title, and updated _at, which is exactly the conversation summary shape we typed earlier. Don't forget the DB facade import at the top. Now the method that loads one full conversation when a patient clicks it, and we'll build it in 2 careful pieces, because the first piece is a security lesson. Slow right down here, because this handful of lines is the difference between a safe app and a headline. The conversation ID arrives from the URL, and anyone can edit URL. If we naively look the conversation up by ID alone and returned it, a curious patient could type someone else's ID into the address bar and start reading other people's private medical chats. That vulnerability has a name: Insecure Direct Object Reference, or IDOR. And is one of the most common ways real applications leak data. Our defense is this check. We confirm a conversation exists with both that ID and this user's ID, and if it doesn't, abort _unless throws a 404. Notice it's a 404, not found, not a 403 forbidden. We don't even admit the conversation exists, so a snooper learns nothing. Now that we know it's safe, let's load the messages. We pull the messages for this conversation in order. The key filter is where in role. We keep only the user and assistant messages and deliberately skip the internal tool call rows, the behind-the-scenes chatter with a model called list_doctors, and so on. Then filter with fill drops any empty rows. Map trims each message down to just role and content, and values reindexes the list cleanly for JSON. The result is a tidy transcript that looks exactly like the chat the patient originally saw, not the machinery underneath. We return it as JSON along with the conversation ID, because the chat page will fetch this with JavaScript, not through Inertia. Now the route. A get route with the conversation ID as a URL parameter and the curly braces. Because we did the ownership check inside the method, this route is safe to expose, and the habit to carry from this section forever. Anytime you load a record by an ID that came from the user, a URL, a form field, a hidden input, anything, stop and ask, does this record actually belong to the person asking, before you hand it over. It's often just one extra aware clause, and it's the cheapest insurance you'll ever write. Now let's wire history into the chat page from episode 4, top to bottom. First, the imports line needs 3 additions: the history and plus icons from Lucide React, and our 2 new types. history, and plus join the icons we already had. And the two conversation types come in from the types file we filled earlier. Next, the component needs to receive the conversations list our controller now sends, and one new piece of state. The component now accepts conversations, an array of those conversation summary shapes, ID, title, and date. And show history is a simple true or false, controlling whether the history panel is open. Everything else, messages, input, loading, conversation ID, the auto scroll effect, stays exactly as we built it in episode 4. Now a small function, start a fresh chat. New chat wipes the slate. It empties the messages, clears the conversation ID, so the next message starts a brand new thread on the server and closes the history panel if it was open. It's the start over button. Now, the more interesting one, loading a past conversation back in. Walk it with me, because every line earns its place. We close the panel and switch on the same loading spinner the live chat uses, so the user gets immediate feedback. Then we fetch from the show route we just built. And notice, unlike our post in episode 4, there's no CSRF token here. This is a GET request that changes nothing, so CSRF protection doesn't apply. That protection is only for requests that modify data. If the response isn't okay, say the server returned that 404 from our ownership check, we throw, which jumps us to the catch block, and the catch deliberately does nothing. We keep whatever chat is currently on screen, rather than wiping it over a failed load. Failing quietly and safely is a choice, and here it's the right one. On success, we map the return messages into the exact shape our message's state expects, using each message's position as its ID, and drop them straight in, which is why an old conversation renders identically to a live one. It flows through the very same rendering code. And here's the magic touch. We also set conversation ID to the old thread's ID. The moment the patient types their next message, our send function from episode 4 posts that ID along with it, and the server continues the original conversation, memory and all, as if they never left. The finally block switches the spinner off no matter which path we took. Now the buttons that trigger all this, up in the chat header. I forgot to pass down the conversations list as a props to this component. Let's do this quickly. When show history is true, we render a panel capped at a modest height, max, H48 with overflow auto, so 30 conversations scroll inside it instead of pushing the chat off screen. Each past chat is a full width button, title on the left, date on the right. The title falls back to untitled chat if the SDK hasn't generated a name yet, and truncate keeps a long title to one tidy line with an ellipsis instead of wrapping. The date gets shrink 0 so a greedy title can never squash it, until locale date string prints just the date in the visitor's local format. No time needed here. Clicking any row calls load conversation with that conversation's ID, and thanks to everything we just built, the whole conversation reappears, ready to continue. I've had a couple of chats with the assistant already, so the history button is showing. Click it. The panel drops down with my past conversations, most recent first, each with its date. I'll click the one where I booked with Dr. Chun. The panel closes, the spinner blinks for a beat, and the entire conversation is back. My message is on the right, the assistant on the left, exactly as it looked. And the new button drops me back to a blank chat with the suggestion chips, ready for a fresh thread. Patients can now see all of their appointments, complete with the reminder flag the AI set, and they can reopen any past conversation and carry on exactly where they left off, memory intact. We built both features without a single new table, just by surfacing data the earlier episodes had already been quietly saving. That's the reward for designing the whole database up front. One promise remains unfulfilled. All series long, the assistant had been offering email reminders, but no email has ever actually gone out. In the final episode, we make those reminders real, with a scheduled job that sends them automatically. See you there. Throughout the series, our assistant has been asking patients, "Would you like an email reminder?" and saving their answer in the reminder opt-in column. In this final episode, we make those reminders real. An email, a command that sends it about 24 hours before each appointment, and a scheduler to run it automatically. This is the last piece. Everything it needs already exists in our database. Here's the pain we're solving first: building an email by hand. The HTML, the styling that works across every mail client, the plain text fallback, is genuinely miserable work. Laravel spares us all of it with a mailable class plus a markdown template. A mailable is just a PHP class that represents one email. Let's generate ours and ask for the markdown flavor. This command generated the mailable class and the blade file, which has the markdown format for us. Open the class first, and let's work on it. A mailable has a few small methods. Let's do the constructor first. This is how we hand the email the appointment it's about. Notice the word public right there in the constructor. That's constructor property promotion, and it does something lovely for us. By marking the appointment public, Laravel automatically makes it available as a variable inside the email template with no extra wiring. So whatever appointment we build this mailable with, the template can just reach for it. Next, the envelope, which is the outside of the email. The envelope sets the subject line, and look, we're already using that appointment, pulling the doctor's name right into the subject so it reads reminder, your appointment with Dr. Chun. A specific subject like that gets opened. A generic reminder gets ignored. Now the content, which points at the body. Content just tells the mailable which template to render. The markdown view at mail.appointments.reminder, which the mail command already stubbed out for us. Let's go fill that template in. We'll build the email body with Laravel's Markdown Mail component. Start with the wrapper and a greeting. Here, we pass the patient name and a greeting to make them feel belong to this application. That xmail : message tag is Laravel's built-in email layout component. It wraps everything in a clean, tested design with a header and footer, so we don't handwrite a scrap of HTML. Inside it we write plain markdown. The hash is a heading, and the double curly braces print the patient's name. That's the appointment, our public constructor property, made available. Now the actual details and the sign-off. Two bullet points, the doctor with her specialty and the when. And notice we can call format directly on scheduled_at. That only works because back in episode 2 we cast scheduled_at to a date. So it's a real carbon object here, not a plain string. A decision from 5 episodes ago paying off right now. The format code produces something human like Monday, August 3rd at 9 a.m. Then one plain sentence telling the patient what to do if plans change. A reminder email that offers no way out just creates anxious patience. And we sign off with the app name pulled from config before closing the component. That's a polished, responsive email for about 10 lines of markdown. We have an email. Now we need something to decide who gets one and when, and to actually send it. That job belongs in an artisan command. A task you can run from the terminal and, in a moment, schedule to run on its own. Let's generate it. Every command has 2 identity properties at the top. Let's set them. The signature is the name we'll type to run it. Appointments : send reminders. The colon is just a naming convention Laravel uses to group related commands. The description shows up when you list all commands, so future you knows what it does at a glance. Now the handle method, which runs when the command fires. The most important part is the query that finds exactly the right appointments. Let's build it carefully. Read these 3 conditions, because together they're the whole brain of the feature. Where reminder opt-in true. Only patients who actually ask for a reminder, the flag our AI set. Where null reminder sent at. Only ones we haven't already emailed, which is how we avoid sending twice. And where between scheduled_at now and now plus a day. Only appointments happening in the next 24 hours. Get those 3 right, and everything downstream just works. We also eager load the doctor, since the email uses the doctor's name. Now let's actually send. Make sure to import each class we have here, the mail helper class and the appointment reminder mail class. For each appointment, we send our mailable to the patient's email. Notice we hand the appointment into the mailable right here, which is what fed that public constructor property. Then, immediately, we stamp reminder sent at with the current time. Do not gloss over that line. It's what guarantees nobody gets the same reminder twice, because next time the command runs, that where null check we wrote will now skip this appointment. Picture the alternative, a patient getting the same reminder every single hour, all night. That one update line is the difference between a helpful nudge and an angry unsubscribe. The info line prints the appointment number and the address it went to, so we can watch it work in the terminal. Finally, wrap up. We print a small summary of how many went out and return success. That's an exit code that tells the operating system and any scheduler that the command finished cleanly. Commands should always report whether they succeeded. We don't want to run this by hand. Let's schedule it to run every hour. In Laravel 13, The schedule lives in routes/console.php. That's it, one line. Every hour, Laravel runs our command, which catches any appointment now inside the 24-hour window. On a real server, you'd add a single cron entry that runs Laravel's scheduler every minute, and Laravel takes care of the timing from there. The docs call it running the scheduler, and it's one line of cron tab. Locally, we'll just run the command ourselves, which is exactly what we do next. How we test emails locally without setting up real email. The simplest option is Laravel's log driver. Instead of sending anything, every email gets written into the application log file where we can read it. One line in the env file. With this, sending an email just appends it to storage/logs/laravel.log. Nothing leaves your machine, no account needed, no setup. Now we need an appointment that our commands query will actually pick up, one that's opted in, unreminded, and inside the next 24 hours. Rather than waiting for real time to pass, let's nudge our latest appointment into the window with Tinker. Start a new Tinker session in your terminal. Then, run the following query. This grabs the most recent appointment and updates it to be 3 hours from now, opted in, and never reminded, ticking all 3 of our query's conditions. Now run the command and watch. This went well. Now open a new terminal window and run the command to send appointment reminder. And there's the output. Reminder sent for appointment number 1 with the patient's email address, and then 1 reminder sent. Let's go read the actual email. Scroll to the very bottom of the log, and there's the whole email. The subject line with the doctor's name. Reminder, your appointment with Dr. Sarachin, the to address, and the rendered body with our greeting, the doctor bullet, and the human readable date. Everything are mailable and template produced, captured in the log. If you want a prettier preview that looks like a real inbox, tools like Mailpick give you one. But for confirming the feature works, the log driver is perfect. Now, one more run, and this one matters. 0 reminders sent. That is not a bug. That's the best output of the episode. The first run stamped reminder_sent_at. So the where null check now skips that appointment. We just proved on screen that no patient can ever be reminded twice, no matter how many times the scheduler fires. That's the whole feature verified end to end. And that completes the app. A patient chats in plain English. The AI finds the right doctor, checks real availability, books the appointment, and offers a reminder. Admins manage doctors and schedules. Patients see their bookings and past chats, and a scheduled job quietly sends the reminders. Exactly once each. You build all of that on Laravel's first-party AI SDK. And because the SDK is provider agnostic, you could switch from Gemini to Claude or OpenAI by changing one attribute. From here you could add cancellations, SMS reminders, or stream the AI's replies word by word. Thanks for building along. See you in the next series.